is somebody here? Who is this one? Denial with potential risk. Read AI. Who is this one here? Oh, I need to allow this person. Okay. Anybody using this AI something? Do I deny this one?
Someone might be just taking notes using AI.
Oh, okay. Okay. So, all right. So today we look at merging and joining data in pandas. Our focus is combining data sets using Python pandas again. Our learning objectives are that we understand data set merging, very key in scenarios, of course, where you're going to have engagement on multiple, let's say, data sets. Maybe you have stations, so you have station 1, 2, 3, and 4, and so forth. You have departments, you have, many different data sets. Therefore, learning objectives are that we understand dataset merging, identify the join types, use, of course, pandas uses the pd dot merge, the concat for concatenation again, or maybe the join here. I'll look at some of those, then you can build on that again in your reading. Why merge data? Real data sets come from multiple sources, like I mentioned. In this example that we are going to use today, I'll look at students, for example, data set, we have scores, we have attendance. But again, in the other real world examples, you could have weather station, let's say, data sets. Maybe you have station Kampala, you have Mbale, you have so forth. Then for people that use satellite data, you could also want to actually call that, is it fusion? I think the word is fusion, where you combine, let's say, data sets from multiple sources. The aim is always to get better prediction models. The only challenge, of course, that you are going to find is on the time lags on when these data sets are recorded. For example, for station weather data, I imagine that is recorded on hourly basis, so every after 30 minutes. Then for satellite, you find a scenario where, for example, if you are going to use MODIS datasets, MODIS, let's say Terra and Aqua. Terra is always morning. I think Aqua is always in the afternoon. So you have the satellite that passes through Uganda, for example, early in the morning, and let's say early in the afternoon. So there are time lags, of course, between when those records are captured. So you may miss out, let's say, on station data if you have to combine that with the satellite data. So sometimes those time differences would affect, let's say, your model performance as well, and many other scenarios. But that does not stop you from using different data sources. If there is a way that you can fuse those data sets such that you create one comprehensive data set for modeling, that would also be very much okay. But the idea, of course, is to learn how to merge data sets. What data merging is combining data sets using common columns, also called join or intersections. Example here that we are going to use could be students identification. Those primary keys, maybe yes. In one table can be primary key, in another table it could be a foreign key. You guys are doing databases. I hope you understand what I'm talking about there. Primary keys, for example, unique identifiers. An example here, student ID, must not repeat, for example, as primary in another table, but can actually be defined as foreign key, let's say, in another table. Foreign key reference column from another data set, an example, student ID in score table can be defined as a foreign key. key there. Types of joins. Today we are going to make use of the inner join. Normally, inner join or the intersection should always maintain only records in both tables that have a unique kind of identification. Then the left join, of course, they want to keep only records, I guess, in the left table. Assume that you are joining a student and scores table using the student ID in the student table. Therefore, only records, of course, that are unique to, let's say, the students table on the left using the left join, let's say, syntax there would be maintained. Therefore, maybe on the other side, the right join could only look at only those records that appear in the right table. I assume that if score table has the one that is being joined to the students table, then of course the interest is to only make sure that the records in the score table, of course, are maintained. Outer join, of course, will keep all the records in both tables, regardless of whether some records are missing in the other table or maybe not. Inner join therefore returns only matching rows, and here, of course, you are going to make use of the PD merge. So you have, let's say, a data frame 1, 2. In this case, where we use the primary key on one of the tables as our uh, record to which the merging is going to be affected. And of course, this we are going to demonstrate it the other side of Python as well, or Jupyter Notebook anyway. Therefore, the inner join, that's what it does, returns only matching rows. And those, of course, that are not matching in both tables are always discarded based on the inner join there. Left join returns all rows from the left data set, adds matches from the right data set. Again, here we are going to use that, and we are going to use that. And of course, some records in the left, regardless of whether they have records in the right table, of course, will be maintained, and we'll see that there. Only those that match, those that don't match, maybe could have none kind of or missing kind of, let's say, values there. While the right join returns all rows from the right data set, adds matches from the left data set. Again, we'll see how this works, but the syntax there again is the PDF merge. Again, you can merge using, let's say, your student ID. And of course, how is again to use the right checking, of course, to see which records were merged or maybe not. And then the outer join, of course, returns all rows from both data sets, and the missing values become, of course, nuns here. So that's the difference. So because when you are joining, it depends, of course, again on your what you are trying to basically your end goal. But sometimes we study all these things, but the end goal will definitely determine uh, uh, which uh, which of those techniques definitely you are going to apply on your data sets. The idea is that we show you all of them, and then you'll decide based on those real world problems that you are going to be encountering, let's say, in the future. Therefore, the default merge behavior is that default merge type is always the inner join here, which looks at the unique sets, I guess, from both data sets. If you are looking at merging only two data sets, if they are more than that, again, that is what is critical there. Merge example workflow. Again, we load the data sets, check column names, merge, then verify. I will also verify our results there. We are also going to look at merging multiple columns. In this scenario, we use it when one key is always insufficient. For example, maybe you want to use both the ID and the course. So you would want to do this in a scenario where you have to use multiple columns. Again, we have an example here in pandas or Jupyter, which you are going to see for this. Or different column names, again, you can always define those column names, I guess. And of course, the condition be based on either I will see this anyway. I'm just trying to give you a highlight of what will cover the other side. When I talk of a DF1 or 2, those are your data sets that you're going to be using uh, in joining or merging your those data sets or yours as well. Join using the index. If data sets are already aligned, again, we can use this join as an index here. Concatenation, very common, I guess, used when stacking data sets. Here you define the axes on the row and let's say the columns. Again, you decide where to use concatenation, where to use the merge, and merge, which type of merge. Again, that definitely will depend. But of course, for me, I prefer the outer merge. I merge everything, then if there are any missingness, I can use now the other techniques that we have done. Of course, data wrangling has provided us with a number of techniques that you can use to fill those missing lines. Of course, you first check their percentage missingness, which you already know. Then if they are below the required, let's say, standards, then we apply the imputation, which is easier for us to do now. Again, this one we are going to see the syntax is pd.concat that we use for concatenation. On the column again, that's what we do. Then after merging, you can always check your results. These ones we have already talked about them. Ahead for your first whatever records, you can define the number if you want it, the shape, I guess, on the columns and let's say the rows, then the info in terms of structure, and then the missingness where we use the df is now and the totals there. Common errors that some people always make wrong join columns, and that if that is not carefully handled, you are going to, you're like, of course, going to get issues with your models. Ultimately, what we are doing in data wrangling, the end goal is that we're doing this to come up with good or kind of good models. So if you use the wrong kind of join, that would be an issue there. Duplicate records. Again, I showed you how to do this. You can always remove duplicates. You can always do this. This one I've done. Unexpected missing values. This again you can handle with imputation. Wrong join type. Again, that is going to be up to you to decide which technique best fits, I guess, your problem scenarios. Real classroom example. So we are going to make use of the students' CSV, scores, attendance, and combine these, I guess, in what you are going to do. And then in your practices, you can always do this. Check keys, check duplicates, choose correct join type, and look at dataset validation. It is also important to check for that the data set actually meets your requirement. That's validation. It's really important in machine learning life cycle. Then these ones, of course, you are going to do that on your own. We just like our norm, of course, this subject really wants us in most cases to run some of these. You run a few examples, and of course, you can also go ahead and so I've been able to put my datasets, I guess, under your data wrangling. Also have my datasets there. This is what we have been using all through our classes. Even at the end, if you wanted, I can give you this. But otherwise, we have I have the course scores table, I have attendance, I have so forth here, which I'm going to use, I guess, in my other side of Jupyter Notebook. So we go ahead now this time around and go to our home tab like we have been doing, and then go to our new Python here. This we go to, I guess, which I believe now all of us, of course, have the capabilities to do so. Okay, so this where we are. I want to resize this for you guys to see some of maybe this could be okay. So my data sets, of course, are this side, and what I do again, of course, I come up with my explainable kind of pipeline. I always do this. Maybe for us, the facilitators always do this, but again, for you that is interested, I guess, in coming up with good pipelines, you can always create some of those markdowns, I guess, for it. So again, we'll import this time. We are going to only use, I guess, pandas here. We are going to use pandas. So the first thing that we do again, of course, is to import our libraries. Import our libraries here. Okay, we import our libraries here. I think that today we're only going to use pandas here. We're only going to use pandas. So import pandas as PD. For join, we're only going to use pandas. So import pandas, I guess, as PD here. Then we go ahead and load our datasets. The datasets I've created will represent student details, scores, and attendance. And these, of course, are from the different sources that I've mentioned, I guess, in the theory there. Okay. So the next thing that we do here is to load datasets, load our datasets again. Remember, these datasets, again, I'm saying that these are from different sources. We can say these from different sources. Just that's the imagination that I want you guys to have. Different sources. EG, of course, here. From our theory, we have the student, comma, we have the scores, comma, let's say we have the attendance again. These are the ones, I guess, maybe I have here. So I'm going to load my data sets as well, the students equals to again pd dot read your CSV CSV. Then of course you can put the name of our file path, of course, for our data set right here. And this one, now I go to this which one is students data set. Students should be this. So I copy this path. If you have it, if you can always memorize it, I have no problem. Okay, here. Then of course the other is the scores. The scores data sets. The scores data sets, and you can copy this. Should be in the same folder. This is called scores. Then the other that I have is attendance. It is also attendance here. So it's just changing changing their names right here because they're in the same location. They are in the same location. But this is a tendency. Tendency equals. Okay. So you also decide to uh, do this, I guess. Students, you have scores, you have attendance, you have attendance here. So these are the three data sets that I'm going to use right here. They are not big data sets. They are not big data sets. Some have 7 records, others have 6. Another has 6, I think. Then the other has this 6 or 8. 1, 8, I guess. Because 4, these are 8, 7, and because the Z is also counted there. 7, I guess, and 7 here. So those are the data sets that you are going to use for to demonstrate. Because I'm demonstrating the these different merging, let's say, syntaxes here. I think that's the idea. So to do this, first of all, we first view the rows in the data sets. It normally helps us understand the structure before merging. Before merging, you may also want to familiar yourself with this information. You can always view these are common practices that we can't always skip. Always view the let's say the first few rows, few rows of the data set of the data set here. This helps us understand. Again, I want to explain to those who are not there. Helps us understand structure. Normally the structure before merging here. The structure before merging. That's the idea. That's why we are doing this. If someone, of course, would have an issue, this is why we are basically doing this. So you can print the student's data set, print its head, print the scores, check its head, for example, print attendance data set, also check its head. Just and to me, I find this, of course, appropriate for us to do because we are learning. While, of course, some of you guys are already a bit there, but not everybody, I guess, maybe is at the level with everybody there. So students data set. So you have the students data set, I guess, from above there. Now you have a student data set right there. Then we can also go ahead and print its head, for example. Print students data set, students data set. Okay, so we want, let's say, print its head here. Students head, students dot head. Students, let's say, dot head. Then you also have the other ones. I can copy this and paste. Of course, I'll send you this. So the other data set is the scores, the scores data set here. The scores here. Scores here. Data sets. Scores data set. I think also have that one there. It's said here. This. The idea, of course, is what I've explained above. I'm doing this. Scores dataset dot head. And then lastly, I guess you have You have the attendance data set there. So you can also copy this if you wanted. Attendance, attendance, attendance. Think attendance data set. So you can also go ahead and print it set here. Attendance, data set here. But some of this information, of course, we have already seen it from above, but it is always important that you view this information to understand the structure of your data sets before you go into merging. So if you look at our student data set, this is now much clearer. It has student ID, we have name, gender, program, I guess, and the year. Again, of course, to careful with what you are doing here. Scores data set. Again, now, because remember that from the theory, we are going to be merging, I guess, based on the student ID as a primary. Scores, of course, it becomes a foreign key there. Then you can see also attendance here as also a student ID, rate, I guess, and also classes based. So this is a very good data set where we can practice the other different merging functions. So check the other from the theory, we are required to check the column names. Column names are again important. Merging always works best when we know the actual key columns. Again, that is very important. When you know the actual key columns there. So always check. Again, always check the column names. I always check the column names. Uh, column names. Column names. We are saying that merging again works best. When we know the actual key columns. When we know the actual key columns here. Okay, and here we are going to print. Again, of course, we use the print here. Then, of course, you can put your student columns. Check the columns, I guess. Check the columns on the scores, and check the columns, I guess, on attendance. So the syntax that we use again here is that open the bracket there. Then you can check your students columns. Columns here. Columns, you can put those full quotations again. Then comma, students. From the students table, we want students columns here. Students columns from the students table. Dot to this one we have used it. List here we have used this one, I think, in our other procedures here. Okay, then you can put for the rest. So for the rest, you can simply copy this, then manipulate the rest. I think the other table is the scores table. The scores, so you want the columns in the scores table. So here again, check the and again students columns. Okay, name student is not defined. Line students columns dot. Where do you find see a problem, guys?
I
Student
think it looks like it's supposed to be students dot columns.
dot
Not
col
so.
dot
Column.
columns.
Yeah, because you're trying to reference to the students, and then you need columns from there,
Yes, is dot
and then you're
columns.
creating the view to a list.
Dot columns dot tourists. Yes.
Yes.
Dot dot. Is this right? Okay, so student columns we have ID, name, gender, program. So I think this okay. It's a dot, not the other. Thank you, my guys, for always doing this. Okay, so now the next thing that we'll do is that we use the inner join. On the inner join, what we have mentioned, if we go back to the theory, we want to understand what the inner join does. Inner join it is really important to understand what it does. So returns only matching rows. So what happens here is that only matching rows in the students table based on the ID will be projected, I guess, after merging. Only those that match on the student ID and rather on the student table and the scores table, of course, based on the primary identifier, which we are calling the student ID. So we are going to check, of course, after the merge, which of those will have been merged, of course, that have that unique kind of contribution. And if I look physically, if you look at the student's ID, 101, 102, 103. Okay, scores table 101, 102, 103. Seems like those, I guess, are unique there from both tables 102, 101, 102, 103. And if you look at, I guess, this other table doesn't have. So we'll see what happens, I guess, when we do, let's say the merging there. So we are going to start with the inner join. Then you definitely are going to decide when to use these. Inner join keeps only students that appear. This one should be able to keep only students. Keep only. Again, I think we have to be note this carefully. Keeps only students that appear in both appear, I guess, in both data sets here. And from the physical interpretation there, I guess if you look at this small data set of ours, only those, of course, that are unique in the different data sets, I guess, will be merged. Okay? I think that's what that means. So here the pandas allows us to use what we call the inner merge. Inner merge is what we use in this kind of scenario. Inner merge should be inner merge should be equal to pd dot merge now. P dot merge. So we are going to create a new data set called or data frame called inner merge using the pd dot of course dot merge there. Then, of course, we are going to merge the two tables. One is the students table and the scores table. Then we define, of course, the criterion, which is going to be on which, of course, which primary key are we going to use, I guess, and so forth there. Let's use students, comma, again, the scores, comma, on. Now this is what is actually important. Again, when you are defining, this is what is important. On is equal to, so you now define your join column at which the is going to operate. So here we are going to match, let's say, on the student ID. Again, of course, check that this variable is well written from both tables there. Okay. Then how, of course, the how here, how again is also key. How is going to be, I guess, using which type of join are you going to use? We are using the inner join here. Okay. So be specific here and say that you want to use the inner join. Okay. Then close your bracket, of course, that closes the entire statement. Then now we can view our inner merge here, which you can come and write below. Inner merge, our new data frame. I want to see, of course, which kind of records, of course, we won't have. But what is important, I guess, is the merge. Merge, of course, which tables which we have defined, and also most importantly is that we don't forget the primary key identifier and the type, of course, of join you'd be using in this example. So when we join, this is what we get. I want you to critically and see whether all the records, of course, were encoded. Because ideally we say that only those that match this criterion will definitely be merged. So if you look at our tables, I think there's one which is 1 0 2 3 4 5 6 here. So and 8 here. Okay. So I think 107. Was it 107? 107 was not merged. Okay. Because I think 107 didn't have, it had missing information. So if you look at, if you go up here, of course you are going to check from your data tables, but that's what that means. So it merges only those where the criterion, of course, I guess has been realized. Only those records, of course, are captured in the final merge data set. So remember that I think we had in the first data set, student were they 8, then 7, but now I guess in the merge data set, for those, of course, where the ID was unique in both tables are the ones, of course, that are projected. The other information, of course, is discarded because that is how the inner join basically works. Okay. I don't know whether you'd want a scenario like this, of course, where some records are exempted. In some scenarios, I wouldn't think that is okay, but in some scenarios, of course, it could be acceptable. So maybe some people want to avoid duplication or whatever you call it. I don't know. But it is always important to understand which technique, of course, best fits, and let's say the kind of scenario to which you'd be handling. Are there any questions maybe up to this point before we move to another? Are there any questions at this point? Hello?
No, we're good. I'm good. Not we.
Okay. Let me just give me a minute. I want to send a message. So the next thing that we are going to be moving to is that uh, now that you know the results of what that does, you can even go ahead and check. Okay, let me first send this message, then I will go back to that. And then go back. Just give me a minute as you also try to internalize. Okay. So what we do is that we check, of course, how many rows remained after merging, and those are the commands that, of course, I'm going to give you. Maybe you can tell us those ones. How do we check this information? How do we check this information? Andrew, can I trust that? How do I check this information? Using this.
Using this info. You want to check.
Yes.
You want to check the number of rows.
We want now to check how many remained after merging.
Yeah, you can use shape and compare with the one that we had before.
Okay.
Hello?
Please mute. Please mute. Mute, please. I'm just sending somebody a message here. Is on my case. Let me do this, then we continue. Okay, so okay, Andrew, go ahead. So you said I do what? So the next thing that we are going, sorry for this, I was trying to send a message. So here I want us to, of course, check the results. Check the results. Check the results after merge. After merge, this would be important, of course. We want to see how many rows, I guess, remained after after merge here. And Andrew, you are telling me that I use okay.
Use shape. And use shape.
You can use shape and so forth, okay? But you can also print the rows, I guess. We can also print the rows in students using the lane. I think you know what the lane does. Print the rows in students in the students table. Students in the students table, I guess. Comma here. The lane, I guess, is lane. I've used this one here. Lane students. Okay. This one can help you to check this information. Okay. Then, of course, you can also put the other tables, of course, scores. Then also we have the of course, I think we have those two. We have those two there. We can also use this. Copy this. Now rows. Let's say in the scores table. In the scores here, again, be specific and put your scores. Then we print print, of course, our inner merge now. The inner merge, of course, is the new table, I guess. Okay, I hope you don't forget that here. So the inner rows after inner join rows here. You also want to know the rows after the inner join here. Okay, so here you put a lane again, then inner merge. Remember, this was our new data set there. Okay, I'm not disputing what Andrew, of course, mentioned, but I wanted to introduce this lane here, which can also check for you those records that remained. Of course, you are going to compare what we had in the students, the scores, and of course, after the merge, what remained with the thing. That's what is important. So the rows in the students were 8 originally, rows in the scores were 7, but when we merged, I guess we got 6 of those rows or records, I guess. That's what that means. So I hope you're able to tell the difference with when you have to merge and only keeping records, of course, that follow the criterion based, I guess, on the unique kind of attribute which we mentioned as the student ID in both tables. I hope that has clearly been understood on this part here. Now we want to go to the left join. So inner join, that's what happens, returns only matches, or only matching rows, of course, in both data sets. I have been able to see that. Left join, we are saying that returns all rows from the left data set, but adds matches from the right data set. Add those that match in the right data set, of course. In this case, would be the student table, because you are adding the other table or the other data set called, let's say, scores. So you have the right and let's say the left tables. But here, in most cases, it's more like the left table has a more priority, I guess, over let's say the scores table. Only return all rows from all the rows from the left data set that match those in another table. Only those that match in the right table. That's what the left join does. Okay, and that's what we are going to go to next. So we have our left join. I want you to select which method definitely is going to work for you in this case. So we are saying that a left join, a left join here keeps all let's say records in the left table. In this case, keeps all, let's say, students records, keeps all students records, I guess, from the left table, from the left table here, even when the scores, of course, are missing. We'll see the missingness now this time. Even when the scores are missing, even when the scores are basically missing here, we are going to see this. Okay, and that's what we are now going to do here. So left merge. So here we use the left merge again. Left merge is equal to pd dot merge, pd dot merge rather. Then you can still open your bracket here define your tables, students, comma, well, the scores table. Then of course on, which is important, the most important aspect, I guess, of your match is the on function here. On again the student ID, student ID. Again, be careful on how student ID is written in both tables. On student ID, comma, and how of course, which join are we going to use? How equals to, again here, we are using the left this time, the left join this time, right here. Okay, then you can close your bracket there, then call your left merge here. You can call your left merge and check, of course, what happens. But of course, being explainable kind of pipeline, of course, those that will follow this one should be able to see which messages, of course, have been trying to define for each of those codes there. So you can see that regardless of whether the information is missing in the scores table, of course, those records are defined here. For example, record 105 didn't have Python score, I guess, in the students in the scores table, and therefore returns a none. It didn't have statistics score, it also returns a none. I guess the same is for record 107, which didn't have, let's say, the score here on Python and a score, I guess, on statistics. Now, this is how, again, the imputation comes in. If you had a scenario like this, and some records, of course, come without some of these with missingness, this is where, again, you go back into imputation, which is key, I guess, in data wrangling, which we have already done in the previous lessons, because you want to have a compact data set that you'd want to use, of course, to model given kind of machine learning problems. So I guess the choice is now for you to decide which join kind of statement or syntax that you will take. We can still go ahead and verify. It is always important to verify. We can also check missingness again after the left join. But I want to think, of course, those are going to be, you can see them from here because the data set is not big. Some of these issues are. So that's why, again, we go ahead and check missing values, I guess, after the left merge, because the left merge has, or the left join after the left join here. So for you as a learner from your side, you should be able to see or check which, of course, matches in the scores table had missings or showed the missingness that I talked about. Okay, this is what that means. And to do this, of course, you definitely have to use the left merge. Left merge is now left merge here. Remember, left merge here. Dot. You can just simply use the dot. Is now here. Then open and close the dot. Then the sum, of course, you want to know the sum of those values, of course, that are missing. Just as simple as this here. But I should have also written those that will be following that here. you want to understand. Let's say here you want to understand, understand. Let's say students again, without let's say matching scores, without let's say matching scores, in of course in the new merged this say data set. And I think we have seen this from above. But let's run this and see. As you can see that students without matching scores, of course, were this. Here you see uh, Python score, two here, had two missing here. Then statistical score again had two missing. If you go above here, is that we had this scenario on 107, this scenario again, and also here, I guess, and here, which is very easy to address if you are using imputation. So that's the difference, I guess, between what we are calling of course, we have started with the inner join. Inner join, you saw the difference. We have moved to the left join. You have also seen the difference. Now we want to move to, I guess, something else. This time around, we want to go to the right join. Now, the right join from our tutorial here, the right join normally returns all rows from the right data set, adds matches from the left. Okay, adds matches, I guess, from the left. So the right data set should be the scores data set. So the scores data set this time has a priority over, let's say, the right data set, which is the students, let's say, data set right there. So let's do this. We now go to right merge, right right merge, right here, where we say that with the right merge, keeps all records. This one, this time around, keeps all records from the scores table. Records from the scores table, regardless of whether they are in the students table or not. Okay, so keeps all records from the scores table. Okay, and that's what basically this means. And this time again, just like we have made use of this, it is just to do this, but change, of course. If I want, I could copy this, then make some kind of adjustments here. So this will be the right merge. Okay, right merge, pd.merge again, students scores table, on student ID, the how this time around, and this is on the right data set here, which is basically the scores data set. Then you can do this, change that from left to the right merge, which is your new data set, I guess, at this point. Okay, and then you can basically run this and see what happens this time around. So all records, I guess, on the right data set, which is the scores, have all the information included, I guess, in the new table called the right merge. And you see that record 109 actually didn't have this other information in the students table. This was not there, and that's why you see you have this none information. But because the criteria was to merge on the right, so all this information is included, but this was not available, I guess, in the left table, which was the students table that we used in this merge how these merging functions basically work. Okay, so that is on the right. We now want to go to another type of merge this time around. The other type of merge is the outer join. Now, the outer join, a very interesting kind of join function, always returns all rows from both data sets. Missing values again become none. I think this is the one I prefer most, by the way. I prefer this one most because all information is included in tables being merged. So it becomes easier for me, I guess, to do the imputation. Okay. By the way, there are many imputation techniques. Why, of course, we have used that rather looked at mean, median, and mode, but the other many others, interpolation, those other advanced machine learning techniques, they are really available. So in other scenarios where you're going to find such problems, make sure that you use some of those other techniques. Of course, if you are to improve your models to a level which is a bit competitive. Okay, so we want to go to the outer join right here. What this does is that it keeps all keeps everything keeps everything from both tables. It's more like this time it's more like a union. Mathematics is not a union. Rather, you did union kind of uh, connections or interconnections. Or it's an intersection. You call it an intersection in mathematics. I think that's what that is. Keeps everything from both tables. Right here. The tables that we are talking about, of course, are student and scores. The others, of course, are not looked at. But this what this command does here. I want to again and paste this. So here you are going to call this outer merge, still on the same. We are keeping the same syntax here. PD merge, students, scores here, student ID. The how again here is on the outer right there. Then of course you can now check the outer merge and see the difference. I say that for me, I prefer using this approach. It's now up to you to decide which approach is best for you. I prefer using this approach because it actually brings all the information from both tables together, so it becomes easier for me to impute the missingness, of course, depending. Again, imputation, I want to be very clear that imputation should follow particular machine learning principles. I mentioned in the previous that look at the percentage missingness. If there are big data sets in thousands, make sure that missingness is below 50% of the total number of records your data set has. Okay. By the way, you can even now for people that are more skilled, what you do is that you can keep reducing the missingness and test models based on the different kind of segments. For example, kind of overfitting. acceptable percentage missing is machine learning data sets. If you have to put this, I think you can get some ideas on how people have been addressing some of these issues. There is no universal gold standard, but industry simulation studies suggest specific threshold for handling missingness in machine learning datasets. Acceptability is typically categorized by percentage of missing values and the strategy required to address them. You can see here 5% generally considered safe to ignore handle. You can see this. Dropping again, you can see missing estimates at completely at random. Some of these, of course, I've taught them. I don't know there was a chapter where we should have mentioned this missing completely at random. 5% moderate requires active intervention. Simple methods like mean, median, imputation are common, though they can distort variance. Therefore, advanced techniques, including k-nearest neighbors, multiple imputation, chained equations, are often preferred to maintain it. I think you can see this 20 to 50% high. Models become highly sensitive to how the data is fed. So, sophisticated model-based imputations, e.g., random forest, XG boost are necessary. And I think this is where now you go with the ensemble based models, because for them they are more robust to outliers. Now, above 50% severe, most practitioners recommend dropping the feature column unless it is critically important. So I've given you scenarios on how, of course, missingness can be addressed using these different thresholds. This information is available. Just punch it in Google and you can decide. So when I say that I prefer the outer join, it is because of what I've seen and interacted with in machine learning modeling, or for me that has dealt with quite a number of data sets. Okay. Are there any additions one would want? Edwin, do you want to add anything on that?
No, it's totally subjective, depending on what you're actually looking at. Because I think the data always tell you how sensitive, how important what you're dealing with is. So it's
Yes.
subjective.
Okay. I think all of us would get this. Really. Now that's the idea. Always do this. It is always important for you. Always do this. I hope sometimes somebody will say I'm biased in the because I always focus on particular videos. Agatha, is this Faith here? Faith, Brenda, are you here? Faith, Brenda, are you here? Because we all have to participate at some point. Faith, Brenda, Faith, Brenda, Brenda, you don't want to mention anything, or you're just hiding there now? What is this? Faith, Brenda, you don't want to talk. Huh? What is that now? Monica, Kosima Monica, she's coming for the first time. Monica, are you here? Kusima Monica. Kusima Monica. Those that are mentioning and they are not, I'm going to mark them as absent. So Auma is absent because she's not. She decides to keep quiet. So I mark you as absent. Kusima Monica. Kusima Monica. So Kusima Monica is also absent. It is terrible. Nakanwa Jaria. Jaria is there. Jaria, are you here? Jaria?
Yeah. Yes, please.
Okay. At least for you are able to. Okay. So, Jaria, are there any additions you want to make in what I've summarized on dataset sizes, or what Edwin has mentioned? Do you have any contribution that you want to make?
No, sir. I don't have any
Okay.
contribution.
Is Wycliffe, you want to say something?
Yes, sir.
Quickly. Yes, go ahead. Go ahead.
Yeah, so at first, I remember we loaded around three tables, but when it
Three,
comes to
three
merge,
tables. I,
yeah,
I, I, I
we have
think that
done
was
for
when I was.
attendance.
Yes, I was. That was at the time when we are viewing the content of those tables. But on the merger, I'm only merging two tables.
Is
I'm
it
not merging
possible
three
to
tables.
merge more than two?
Absolutely, absolutely. Why not?
Okay, then.
Absolutely. Because I think I have something where we're going to merge multiple tables. Okay. Anyway, thank you. Really, when I identify you there, it is not because I'm just trying to make sure that all of us are here and all of us are in position to participate in what we are doing. It is important for you, basically, and not me. That is for you that is here in class. So you can compare join sizes, how join changes the output. That is also important. Uh, and we have seen, of course, this. We have also seen this. But if there is a way that you can compare these join sizes, if there is a way that you can compare join sizes, it is always important. For instance, how the join changes. For instance, how the join changes the output, changes the output basically. Therefore, you can also let me just define these syntaxes again. Otherwise, of course, we have used four of these join statements. We started with the join, inner join, left join, right join, I guess, and the outer join. So we simply print again the rows, in each of those new merged, let's say, data sets. I want to start with the inner join here. Inner, I think it was inner merge. Should have been inner join rows, of course, here. Inner join. Our inner join rows here. Then comma our inner join rows. Then of course we define use the len here because we know how to we want to know the number here. Inner merge. That was our first data set right here. Then of course the rest I'll just simply copy this, and so we had also what we call the left join rows. So here you can put should be the left merge. Then we had also what we call the right here, the right join. Of course, it was also join here, and we called it right merge, if you remember. Then we ended with the outer here, outer. So you can put this as outer, outer merge. I think this is how we define them. This is how we define them. So we can see how these different join statements, of course, change the output of our join data sets. So if you look at the inner join, of course, where we maintained, rather where we looked at the unique attribute from both tables, and only those, of course, that match that criteria were merged into a new inner merge. We had 6 from the previous example. You remember that the left added, I guess, that's why we had some missingness. The right, of course, regardless of where they were in the student or not, I guess, were also included. While, of course, the outer join had to combine all the information in both tables, and that's why you see that the size here was a bit higher compared to the rest. Okay, so that's the difference, I guess, how the different merge statements were able to affect our output. So let's not waste time. We now want to move to the default merger behavior. Is that default merge type is always the inner join example. This one I think I've mentioned. Merge example workflow. This I think this one. I think Elia was asking about this part. Merging multiple. Can we merge? Let's say multiple columns. Yes, why not? We can combine the three data sets, like the ones that I had earlier, I guess, defined. Remember that I had defined the student scores, I guess, and the attendance. Yes, we can do this area. We can also merge more than let's say two data sets, more than let's say two data sets. For example, here we can combine let's say students table, comma, scores table, comma, and attendance. Let's say attendance, let's say table here into let's say one kind of joint table. Let's say into one let's say joint table or joint, let's say data set basically, not just simply a table, and one joint kind of data set. So here we can make use of let's say merge all, for example. You can merge all of them. So merge here. So you can say merge, let's say merged all here, all here, merged all here. Could be equal to again pd.merge. We use the same syntax here, pd.merge. Then you can put the names of the tables, students, comma, scores, comma again, comma there. Then of course criteria is on equals to student ID, student let's say ID right here, comma, the how now is your join statement, which is really important. How, I guess, can be equal to, I don't know if you can decide whether left or maybe right. That we have looked at, I guess. So the choice is yours to choose which option is appropriate. Okay. Then of course, merged well again, we can now add another table, which is let's say attendance here. So here you want to add another table. Of course, our new data set is going to be merged all here. That's the idea. PD merge. Therefore, here you are going to have the merged all, which was our new table, not the new data set. Merged all here, comma. Then, of course, you can now add the attendance table. The attendance, which area was talking about. Attendance still, I guess, is on the student ID, because we want to believe that primary key, of course, exists in both tables. Again, still maintain your left there. Okay, then you can print merged all, data set here. Merged all this the new data set now. We are calling it, let's say, merged all here. And you see a difference, of course, when you have to merge, let's say, both tables, more than three tables. So you can see now the other columns or variables that were not in the previous are now included right here. Attendance rate and class missed. These were not part of, let's say, the other data sets that we had originally, where we combined the two. For instance, this one here. We only don't have the statistical score, but when you add the attendance, attendance of course had columns such as attendance rate and also class missed. Again, why we use the left, you wanted to keep everything, let's say from the left table. Okay, we wanted to keep everything from the left table, and that's why, of course, you have the missingness that we see in some of the records, such as Python, and even actually on the attendance on the 104, you could also see these instances. So yes, it is true, like what you have mentioned earlier, that we can actually merge more than one data set. And I talked also of validation. Validation is also important. Validation. Some are your data sets validated? So validation. These are, machine learning is so good in a way that it follows a sequential kind of steps, which are verifiable really. These steps are basically verifiable, and therefore you can always go back and check all the validation steps to make sure that they have been what they have been captured in your pipeline. Normally, what you are building is a pipeline of our models, following, of course, all those steps that we talk about, right from dataset loading, wrangling, EDA, what we call exploratory data analysis, into splitting the dataset, of course, training and so forth, standardization or what we call normalization, before you go into actual data split and being able to run your models, of course. If you are going to use the cloud, good again for high intensive, let's say, model pipelines, because if you are using a standard CPU, sometimes models may take a very long time to bring out results. But again, of course, if you are going to build deployable models, you're also looking at a scenario where you also compute what we call computation overhead. Computation overhead is more into the how much, of course, the model has taken during the training process, because you don't want to deploy models, of course, that of course don't have that fast kind of convergence. It is always important that the models are faster, of course, for deployment and final usage. So let's validate the final merged dataset, let's say dataset. Here, of course, after merging, always inspect the shape and missing values. Again, as I mentioned at the beginning, always inspect, inspect shape and shape here, and missing values. Very important here. Always inspect shape and missing values. Okay, and of course, to do this, you just simply print the shape of your merged. Remember, the new data set is merged all, so you just simply use the shape there. So you can print, open the bracket here, print the shape, shape right there. Yes, somebody is asking it there, or you are just unmuting. So print shape of our merged all, I think was the merged all. Let's say dot shape there. Of course, you want to check missing values. You can also print for print missing values, which is actually important, very important for you to check missing values, missing values right here. Okay, that is really important, because Then you can also check print still merged here, merged or merged print you merged all. Then of course you can find the isna that I think we have already done that. Merged all dot isna isna here dot sum here isna is now I think that's the right one there dot sum this other bracket here for opening. It's very important, I guess, for you to check some of that information. So if you go now to the missing values, I guess you can see that most information is available apart from instances of here on Python and then a tendency here. Because remember that here we use the left merge, which also includes missing records. Let's say in one of the priority tables, if you use the outer again, you could have had missing values. But if you use the inner, you would only have had the and I think if you want it in your practices, instead of using the left here, you can try using the inner. And the inner, I guess you'll not have any missing records. Maybe we can actually try it. Let me check this student ID on attendance if you but these are things you can always do. I can't always do everything for you for sure. Just do some of this and check out the difference with where you use the left or the outer, rather the inner, and see the percentage of records, of course, or how many of those records could be missing. But the shape, of course, gives us about 8 rows and, of course, nine columns. When you add the columns from the 3 tables, it comes up to 9 of those variables or features, I guess. Should be these ones here. 1, 2, 3, 4, 5, 6, 7, 8. And these are the ones I'm talking about. These are variables or features. Then the records here, what of course the shape is projecting as 8 of those. Actually, all the dataset information is basically included in the left join statement there. So validation, I guess, would be finished. You can also merge on multiple keys. Sometimes one key may not be enough, so you can use, let's say, a student, and maybe you have another table like the course table, and therefore the idea is that you also want to use multiple keys for search. And I think, let me do this. You can also merge. You can also merge. The other thing is that you can also merge on multiple keys, on multiple, let's say on multiple keys. Sometimes, of course, you can say that sometimes, again, those that will be following this pipeline, sometimes one key is not enough. It is not always enough. It's not always, let's say, enough. Okay. So we use maybe in this example, we can introduce another table. This example, let's use, we can use, let's say, student ID. We use the student ID, maybe, and course, and course. So it means that we may want to, let's say, get another table, which may not be part of what we have. And I think I should have a table for this. Let me see if I have the course table, scores. So we have the course scores table, which is right there. No, but do I need this anyway, we have this course scores table. So that's the one that has the courses. Let me open this for you guys to see. This one I think should have what the information I need. Oh, you need control. What is this now? About file. Let me open this course scores. Because I want to see if I have that record code course there. Okay, so we have the student has also student ID, but also has the course, and let's say the score here. Okay, the course. So where you can actually merge on such column here. So merge on sometimes one key is not enough, so we can also use student ID, I guess, and the course. So for some reason I need to load this table. So the table that I need to load is the course scores. This course scores. Course scores here. Course scores are here. Is equal to pd dot read the CSV again. Then of course you now have to. I now need to put this table's path, copy this as a path, and I want to bring it right here. Bring R here as the absolute path as well. So for just what I'm basically doing. Then of course I have a course attendance. Course attendance, I think I already have this. So I'll simply go to course attendance. It's just the same kind of. So I need this. Need to copy this. So here, this is course attendance. Course attendance here. So here I'm going to change this to attendance. I hope you know what I'm doing now. Of course, I'm now getting our path, of course, for the files that I definitely have, which are already on my system. Then here now we can use the multiple key. The multiple key here. Multi key. The multi key. Multi key dot let's say dot merge equals to pd dot read the CSV, read the CSV there. Okay. Read the CSV pd merge key dot merge equals pd dot should be pd dot merge. Pd dot merge, then open, and then you can now put your different information. We have the course score, course scores. So make sure that you type that to the way it is. Course scores, comma. We have course attendance. Write them the way they are above there. Course attendance. Course attendance should be this. And put this here. Course attendance, comma. Let's say on, because this time around student ID and student ID and the course. Okay, student ID and the course. Student ID, comma. Then of course we have also the course right here. Course I think is also capital C, Again, you check your data set, then you can close this comma. Then how, let's use the how, which is really important. We are going to use the inner join. Okay, how is inner join right there. Okay, then you can close. Now you can close this. You can close this. Just as simple as that. And then of course merge key here, because it's merge key merge merge key merge key merge merge key merge. Type this merge key merge. I think we are going to do it.
Okay, that one will be okay because it was going to give us an error.
Yes, yeah, you're absolutely right. So merge key merge. We are going to get an error here. I noted that also. I think the rest should be okay. Should be okay. Oh no, it's actually not okay. Course, key error, course is capital. Course here. Student, is it capital? Course, it's capital actually. On student ID and course here. I doubt where it's going to have an issue here.
The course in the file, the name in the file, the location, the path.
The path is not course course. The path is actually here. Course, course. What is this? Let me check. It course. Oh, I think it is scores. Okay, is that the case? Scores. Okay, should be scores. I think. Check course scores. Course attendance. So, and let me first verify this underscores. Let me first check this one here. Should be scores. Let me check. Just a minute. Let me verify this. So it should be score. Python student ID. This is Python score, statistics score. So it should be course scores, I guess. Course scores. I think I'm right here. Should be course scores. Course scores. Wait. Course scores. Let me check this path again. Check the path again. Okay. Click course scores.csv course attendance course attendance key merge pd merge course attendance. Oh, isn't this attendance just?
Yes.
This attendance.
Mm.
Attendance. Let's see this. Attendance, so student ID, I guess on the course. I still have a problem on the course. What am I not doing right? Guys, check. What am I not doing right here? Check the code and make a correction. I'm getting tired now. Check the code and make a correction. Andrew and the rest of you guys.
You first open the Excel, the CSV for course scores with
So the course scores here, we have it is right here. Course scores. Course scores and course. It is
you
course scores and
open and we see the columns inside.
course scores and course attendance. So course scores. So it is actually course here. Okay, that's the course scores. Have you seen that?
Yeah.
Then
Go back to the code.
Then we open attendance.
Yeah.
Course attendance. Course attendance. Course attendance. Again, it is course here. That's course attendance. I don't know where I'm waiting. Well, that should actually be course attendance here. Course attendance. Anything else? Check. So where is the problem?
You can scroll down to the actual error. Won't read the actual error.
The error is on the course. Key error is on the course. Should be spelling. I don't know. Check for duplicates. I
Yeah.
don't know why it is complaining on this part. Okay.
Let's
So check again.
You can run that again.
If it doesn't, we are going to stop here. Are we past time or it's not yet? Then we'll stop here and
you have
it
10
is not
minutes to
working.
go.
I'm going to rectify this one. But I wanted you to study this
But-
and check how the problem is. Because I've
But-
satisfied all the requirements. Yes, Andrew, go ahead.
Because normally, for example, I would expect if the course, for example, we could have the course scores. Let's say if our key, the name of the column for the given key for in a two different data sets is not,
Yes.
the data is the same. For example, let's say the ID 01, 02, 03, they are the same, but the names, the actual column names for those two different data sets do not match. So instead of us using the key, we would actually use maybe on left, and then we define those ones. They will be able to all show up without giving us an error. Maybe that's where we are getting. But everything looks the same. Just share with us the code, and then we'll try out. We can report.
Okay.
Yes,
But I'm also going to make sure that I don't know where I'm getting it wrong here. I don't know that, but okay. I'll show you this one here. Okay. Then you can practice. But I think we have been able to cover a good ground, which is a bit satisfactory. We have covered a good ground. The other part that was left should be this one. I'm going to rectify it before I send you this. But let me go back here. Multiple columns. This one we have done. Different column names. I think this where we are
yeah,
not
that's the one.
reached.
Yeah.
This one we have a problem.
Because that one would join
Is
with the
here
different column names.
merging multiple columns. This way I'm getting an issue. And then I'm going to try and rectify this before I send you this information. Then what is left is concatenation. I think we actually almost coming to the end. So I just let me rectify that, and then the concatenation you can basically do it on your own there. Okay, but we can also let's check before we close, just keep on. It is not always good to leave some of these things hanging. We can make use of our tools which are available to rectify this. Genuine. I always prefer to use genuine here. Very good at also correcting some of these mistakes. Let's check where the problem is. Check error. Sometimes you are always allowed to do this. Don't worry about this. Check error. You can always check errors using the tools available. Programming is not like those years where you would suffer with many things. Please don't go off. Don't go off. Let's first rectify this before we move on. Okay, let's see where the problem is. I didn't see any issue. This guy is also with money these days. This guy is with money these days. They are serious. They are very serious with money. $45.
Just paste it actually in Google. It will give us. The AI will pick it up from there.
Student is missing. Student ID course is missing for 100 pandas will throw kill. Okay, I put in Google. Check it maybe is there. So what is it telling us here? Load dataset. This one is loaded. Merge student course. Display merged result. Course then the name must be passed as a parameter key one. Let me check. Take this here. Let me take this right here. Okay. So dataset loaded, I think. Yeah. Course attendance. What else? Oh, so what was the problem?
Typo.
Isn't it the same code we had used? So you check where do we pay the problem? Was it on the bracket?
We'll not. The thing is, it's now working. We'll not know because it was just, I think, a minor typo, or just a
Was
space.
the
A
bracket
space
maybe?
in between. Yeah,
The
a
spaces
space
are
in between
much.
the quotes.
Sir,
Okay.
I think
Yes, please.
the problem was where there is course attendance here. Before it was just attendance.
Course attendance.
Yeah.
Actually, everything should have been on these brackets here, I think. This were the spaces, like somebody's mentioning. Course attendance, everything you had put the way it is.
No, yeah, before it was just attendance.
Hey, it was just attendance.
Yeah.
Okay, maybe that was the issue. Okay, thank you guys for coming through always. It is always good to have this good interactivity with you. Programming is like that. So we always learn from our mistakes, which is okay. Otherwise, it is not easy sometimes to master some of these concepts really without making mistakes. Unless if there are any questions, but today we can end from here. Then we meet the other weekend. Are there any questions you want to bring forward?
Okay.
Any questions